At this point, you guys have a little background with the discovery of the atom and the different components or the particles that reside within the atom. This page shows you some of the basic vocabulary that you should have taken from the textbook. If you don't have these terms down, you might want to pause the video at this point because the rest of the video assumes that you know what these terms are. So if you want to pause the video to get these terms down, you might want to at this point. The periodic table has a plethora of information. Sometimes in the past, there's been a little miscommunication, maybe in middle school, about what some of the values are on the periodic table. So I brought up a simple example of an entry on the periodic table. This is for carbon. Make sure you realize that the number that resides on the periodic table that has the decimal is not the mass number. This is the atomic mass. And I know on the previous page you've written down the difference between mass number and atomic mass. They are not the same thing. And mass number is not just this value, this atomic mass number rounded to the nearest whole number. It's a way to estimate possibly what the mass number could be, but because each element exists in different isotopes, each of those isotopes has a unique mass number. So please, if your teacher in the past did that, please get away from doing that. So the atomic mass is the value that's located on the periodic table. The mass number is not located here on the periodic table. We're going to do a few example problems that we'll also be doing in class. You'll be asked several times to fill out a table that's similar to this. This is just using your periodic table to gain some information about what are the particles that reside within each atom of a particular element. At this point, you might want to have your periodic table out. I unfortunately don't have one to pull up on the video that will work the way that we want it to. So if you guys could have your periodic table out either from the back of your textbook or from your planner, that would be great. But you need to be able to fill out a table that looks like this. If you're given the element name, you should be able to easily find the symbol on the periodic table or just use them from your memory. So for hydrogen, the symbol is going to be H. The atomic number, the number of protons that are in the atom of the element, is going to be 1. Now, here's where the difference is between these two versions of hydrogen. If you see for the first example, the mass number is 1. If the mass number is 1, that means we have 1 proton and 0 neutrons because the sum of the protons and the neutrons gives us the mass number. The protons is always 1 for hydrogen because that's its atomic number. So in this case, the number of neutrons will be 0. Another way to think about that, I'll write it at the bottom, that the number of neutrons, if you're trying to find that, is the mass number minus the atomic number, or the number of protons, whichever way you want to view that. Now, most of the time, we're going to make the assumption that the atoms are neutral, because most of the time atoms are neutral. We will get into some cases later on where they are not neutral because the amount of electrons has changed. But for now, let's assume they are. So if the atom is neutral, that means they need to have the same number of positive charges as negative charges within the atom. So the number of electrons in this particular isotope of hydrogen would be 1. Let's look at the second example. I'll choose a different color here. This isotope of hydrogen has a mass number of 2. So it's a different version of the same element. It's called isotope. So we have protons, always the same because it's the atomic number. It's like your student ID number. It never changes, or your social security number. It's always going to be the same. It identifies what element we're talking about. In this case, number of neutrons would be 2 minus 1. So we would have 1 neutron, and again we would have 1 electron. Now really, you should be able to fill out any missing information that's given to you about an element. So let's do this last one together. Let's say we have Br. That element would be bromine, found it on my periodic table, or maybe you knew it from memory from doing all of our element quizzes. The atomic number of bromine is 35. And I have not been given the mass number, so I got to do a little figuring out. Well, I know that if the atomic number is 35, the number of protons is 35, and the number of electrons is 35 because the atom is considered to be neutral, or it's assumed to be neutral. And now in order to find the mass number, I need to add up the protons and the neutrons. So I add up these two columns. So 35 plus 55 would give me a mass number of 90. Notice that in a chart that asks for a mass number, an atomic number, and the number of particles that are within the atom, that there are no decimals. Now, because we have different versions of the same element, which are called isotopes, we need a way to distinguish between them. And the way that we do that is we write in the mass number after the element name. So the proper way to represent hydrogen in this example would be hydrogen-1, its mass number. This would be hydrogen-2. Bromine would be bromine-90. So it's a more specific way to indicate what variation of an element we're talking about at any given time. Now this gets a little complicated, and so of course chemists like shorthand ways of representing elements. So the way that you'll commonly see elements represented when we're discussing isotopes is this version, where we still have the element symbol, but then we have two numbers that are represented as superscripts. Actually, one is a superscript and one is a subscript before the element symbol. And what these two numbers represent is the top number represents the mass number of that element, and this is calcium 40 isotope. And the bottom number represents the atomic number. Again, that's the number of protons that reside in the nucleus of that atom. I find that on the periodic table. This number is not on the periodic table, so keep that in mind. Only the atomic mass is located on the periodic table. Another way that you'll be asked to use this information is to be given the number of protons, electrons, and neutrons, and you are asked to write the symbol. So if we have these particles, it's the proton that determines the identity of the element. So if you go to your periodic table and find element number 4, or element with the atomic number of 4, that's beryllium. So I write the symbol here. Its atomic number is 4. And then I add up the protons and the neutrons. I circled those backwards, but the protons plus the neutrons gives me the mass number. And so that's how I would write the isotope symbol for beryllium. And if I wanted to write out the isotope name, it would be beryllium-9, its mass number. Well, then we get into the question of, okay, if we know how to find the mass number, it's protons plus neutrons, where in the world does the atomic mass come from? Where does that number, that value that's on the periodic table that has a decimal, where did that come from? Well, to make a long story short, what happens is that every element comes with many different versions of itself out in nature. So if we were to take a sample of hydrogen, as you read in the book, hydrogen has 3 common forms in nature. Well, those 3 common forms, or those 3 isotopes, come in different amounts or different quantities or abundances. And just like your grade in this class is weighted, the atomic mass for each element is a weighted value. So the bigger the abundance of that isotope, the more it has been used to determine the atomic mass that gets listed on the periodic table. Now you do need to know how to do this calculation, so I highly recommend pausing the video and working through that. There are some other examples for how to calculate atomic mass on pages 81 to 82 in your textbook, but I'm going to work through this one example with you. So the atomic mass is found by taking the weighted average of all the isotopes of that element. So in this particular example, if we've taken a sample of carbon, it comes in 2 common forms. Carbon-12, which it looks like is the most abundant, 98.93% of my sample would be that version. And then a very small sample of carbon would be carbon-13 with only a 1.07% abundance. So I take the first isotope and write its mass down. And then I write down or multiply it by its abundance. Now its abundance is the percent abundance taken out of a percentage. So I need to divide this percent abundance by 100. So this will be 0.9893. And now I'm going to add it to the mass of the second isotope. through 13.003355 and multiply it by its abundance, which will be 0.0107. And then I need to take out my calculator. So let me pull up my calculator really quick. Hopefully your calculator is quicker to find than mine was. And then I need to calculate what this is. Now, this calculator I have doesn't have parentheses, but your scientific calculators will, so it'll be really quick and easy to solve this. So I might have to do this in 2 different steps. So I'm going to take 12 times. Okay, let me fix this real quick. I messed up on my first number here, so it should be 11.8176. And when I add up both of those numbers, both of those products that I just found, I find an atomic mass of 12.01 AMU, and that's the unit that we use for atomic mass. It stands for atomic mass unit. Now, interestingly, if you go to your periodic table now and you look at carbon and you find its atomic mass, you're going to find it very, very close to 12.01. That way you know you've done this calculation correctly. Now if we go back and look at our values, again with our starting amounts, I've got more of the carbon-12, and so my answer should be closer to 12 than it is to 13, because it's this huge percent abundance of carbon-12 that will determine more of the mass than the smaller amount. So keep that in mind. The average mass problems you can always check. First by predicting what your value will be, and then second you can look at your periodic table to make sure that you've calculated it the right way. Again, there are some sample problems on pages 81 to 82. This is just one that we worked through together. If you've got questions, bring them to class next time so we can work through some additional problems together in class.